Okay, guys, we are starting chapter 4 notes now. I am going to make this video a little bit closer. Hopefully this will allow you to see my paper a little bit better because I know we had an issue with some blurriness, okay? So a vector is a quantity that has both direction and magnitude and is represented in the coordinate plane by an arrow drawn from one point to another. Okay, so that is a vector. So then if we go over here, I do need you to write pretty small here. Let me slide this over. Okay, so if we are looking at this here, it says that the diagram shows a vector the initial point, and we're going to underline that because that is a vocab word, or starting point of the vector is P, and the terminal point, underline that, or ending point is Q. The vector is named, okay, and then we're going to do this line with a half an arrow up, okay, it does not go on the bottom side too. P has to come first, then Q, which is read as vector PQ. The horizontal component, underline that, of vector PQ is 5. The vertical component underline that is 3. The component form of a vector combines both, I'm going to abbreviate horizontal for H and vertical V. So component form of vector PQ is, okay, you're going to do like almost like a less than sign, and then 5,3 as if it was a point, and then a greater than sign. Okay, make sure those do not look like parentheses. Okay. All right, so moving on, if you need to stop, stop it. I'm going to keep going. Okay, example 1. It says, in the diagram, name the vector and write its component form. Okay, well, I start at J and I go to K. So it would be vector JK. Okay, and then in component form, okay, I move 1, 2, 3 to the right. So that would be +3. So 3, comma, then up 1, 2, 3, 4, positive 4. Close your vector. Okay, and that is the component form. Okay, moving on, a transformation is a function that moves or changes a figure in some way to produce, to come down here, produce a new figure called an image. Another name for the original figure is the pre-image. Okay, and then if I go down, translation moves every point of a figure the same distance in the same direction Okay, so then as a side note down here, it maps, okay, which means basically moves the points along a vector. We're going to call it AB. To the points. Okay, so I kind of forgot something, sorry. Down here where it says the points, I'm going to put a down caret. So we're moving the points P and Q. Okay, we're moving those along this vector to become points P prime, is how you say that, and Q prime. Okay? So that is that. So then we are going to do example 2 here. Okay, it says the vertices of triangle ABC are A at 0, 3. So I'm going to come over here, 0, 3, label it A. B is at 2, 4, label it B. And C is at 1, 0. Okay, connect those and you have a triangle. Okay, then we are going to translate triangle ABC using the vector 5, -1. So remember, if I have this vector 5, -1, this tells me that I'm going to go right or left, but because it's positive, I'm going to go right. This one tells me up or down, but because it's negative, I'm going to go down. So I go right 5, down 1, and I'm going to do that to every single point on this picture. Okay, so 1, 2, 3, 4, 5, down 1. Okay, and I label this point now A prime with that little like apostrophe. Okay, then do the same thing with B. Label it B prime, and do the same thing with C. Okay, so you can see that image is the same shape and the same size. We just slid it over to the right and down one, okay? So you think of a translation, okay? I'll write this out so you can see it. Translation. See that SL right there? That tells me that I'm going to slide it. Okay, so that's a good thing, good way to remember that there. All right, turn the page. Example 3, it says, write a rule for the translation of triangle ABC to triangle A prime, B prime, C prime. Okay, so if it is asking me for a rule, what it wants you to do, I will show your final answer in a minute. So let's talk about what exactly is happening here. Okay, well, to get from A to A prime, I went left, 1, 2, 3, 4. So I went left 4 and up 1. Okay, so in a component form, that would look like -4, +1. So now I'm going to take that and I'm going to make it into a rule. Okay, so whenever I make it into a rule, we tell you that you're going to start with x, y, but then you're going to move it and you're going to do x -4, comma, y +1. Okay, and that right there is your final answer. Okay, so if it's asking for a rule, this is your final answer down here. Okay. All right, example 4 then, translating a figure in the coordinate plane, graph this quadrilateral. Okay, I'm gonna just show my graph over here so you guys can follow along there. It says that A is at -1, 2, so -1 up 2, label it A. B is at -1, 5, label that B. C is at 4, 6. And D is at 4, 2. Okay, connect those to make a 4-sided figure. Oops. There we go. Okay, now it's telling us this rule. Okay, you're going to take x plus 3 and then y minus 1. So if you would like, okay, you can look at that and you can say, well, that means I'm going to slide this figure right 3 and down 1. That's one way that you could think of this. Okay, another way that you can think of it is, okay, well, I'm going to take this x value and I'm going to plug it in here, and I'm going to take this y value. Sorry, you guys can't see that. You're going to take this x value here and plug it into here. I'm going to take this y value and plug it in over here. Okay, so if I do that, then I'm going to write down my answers first. Okay, so that means that A prime would become -1 plus 3 is 2. 2 minus 1 is 1. Okay, B prime, -1 plus 3 is 2. 5 minus 1 is 4. Okay, C prime, 4 plus 3 is 7. 6 minus 1 is 5. And lastly, D prime, 4 plus 3 is 7. 2 minus 1 is 1. Okay, then once I had those, then I would just come over here and graph those. Okay, A prime is at 2, 1. Okay, and I'm going to label that A prime. B prime is at 2, 4. C prime is at 7, 5. And D prime is at 7, 1. Okay, and then I can count and double check my answers. I went right, 1, 2, 3, and down 1. Okay, and so that is correct. I can see that that is the same shape and size. It has just been slid over to the right and down 1. Okay, so then a rigid motion, okay, that is kind of what I was just describing, okay, how you keep the same size and shape. So that is a transformation that preserves length and angle measure. Okay, so then whenever we have a composition of transformations, that is when two or more transformations are combined to form a single transformation. Okay, so if I look down here, okay, I'm going to change these rules into component forms. Okay, so if I look at this, I would say that's 5, -2, and then -4, -2. Okay, so that tells me that first I'm going to move the segment right 5 and down 2. Then I'm going to move it left 4, down 2. Okay, so let's go ahead and graph our original segment here. So R is at -8, 5. Okay, label that R. And S is at -6, 8. Okay, combine those to get your segment. Okay, make sure they're labeled again. Okay, now I'm going to take that segment and I'm going to move it left 5 and down 2. So there is my R prime. Now S goes again right 5 and down 2. There is my S prime. Now, whenever I go to do this second transformation, now listen carefully because this is like the most the biggest misconception here. Okay, you have to start where you left off. So I am starting with my blue segment or my R prime, S prime. Okay, so when I'm going to start there and I'm going to go left 4 and then down 2. So 2, 3, 4, down 2. Here is R prime. Or sorry, now we're going to call it R. And we're going to put double prime. Okay, so you're going to put 2 little marks. If you can see that, it's kind of running together. Okay, and then S for the same thing, left 4, down 2. And I'm going to call that S double prime. Okay, and then connect those and you have your segment. Okay, so R double prime, S double prime is technically my final answer there. Okay. And that is the last of your notes for this one. So go ahead and go do your assignment. Let me know if you have any questions.